Number 37, multi-correct. A student performs an experiment on measuring friction forces in different trials. For trial A, she pulls a wooden block across a horizontal surface at a constant speed. For trial B, she inclines the same surface at angle theta with respect to the horizontal. Which of the following is true about the friction force on the block surface? So friction force is what we're interested in. So for the first one, let's do a free body diagram. Fn, mg. So the frictional force would be equal to mu k Fn. So the frictional force is mu k mg in the first case. Now in the second case, free body diagram, we have mg pointing down, Fn perpendicular to the surface it's riding on, and we also have this the y component of mg, which would be mg cosine theta. So the force of friction for B, force of friction, would be equal to, well, let's go back. Let's sum up the forces here in the y direction. This object is going to move up that direction, so there is no acceleration. We have Fn in the upward direction minus mg cosine theta in the downward direction equals 0. So Fn equals mg cosine theta. Substituting that in, force of friction equals mu k Fn. We have the force of friction equals mu k mg cosine theta. So when we compare A with B, we see the force of friction is just flat out mg times mu k. But in B, it's mu k times mg cosine theta, which is a portion of mg. So that would make the force of friction in B less. And if we take it to the extreme point, if we raise the slope to 90 degrees, we can see the cosine of 90 is cosine of 90 degrees equals 0. So the frictional force is going to decrease with increasing angle. So B and E.